This is the homework helper for Chapter 7, Section 1 in the 8th grade math workbook. Let's take a look at the first question here. Notice 1 through 5 all have the same directions. They're all referencing this illustration in the upper right corner of the page. And they're asking you to name different features of that illustration. And in question 1, they're asking you to find a right angle. Remember, a right angle, you want to picture an L shape or a T shape. That's two lines or line segments or rays, whichever it might be that's appropriate, that form a 90-degree angle. Well, as you can see, there's actually a whole lot of 90-degree angles, but the one that's marked here is this angle here that's got the X on it. Now, that is properly named as NXP or PXN. You just don't want to say X because this angle and this angle and this angle and this angle could really all be called X because X is just a center point on the illustration. So if we want to go based on that little marker there that means right angle, we want to say NXP or PXN. And since they're only asking us for one, we can stop there. Again, as I prefaced, there's a whole lot of different angles here that are actually right angles. We've got this angle right here, MXN or NXM, that would be a right angle. PXR or RXP, that would also be a right angle. And this here, even though it has a ray in the middle of it, is still a right angle, RXM or MXR. We'll also take a look quickly at number 4. In number 4, they're asking me for a pair of complementary angles. Complementary angles are two or more angles potentially whose sum is 90 degrees. So we're looking for two angles that when I add them together now are going to make 90 degrees. And really there's only one that's going to work in this case. We said there's a lot of right angles, but there's only two that when I put them together make a right angle. And that's this one that I referenced over here that has the ray going through it. This together is going to make 90 degrees right angle. Again, we're looking for that T or L shape, and clearly that is a backwards L. You might have to turn your head a little bit to see it, but it is indeed. So here we're going to say MXS, which is this one here that's kind of on the top, I guess we'll call it, and this one here, SXR, which is this one on the bottom. We could call it the other way, RXS. Are a pair of complementary angles. Talking quickly about 2, 3, and 5. In number 2, where they're talking about acute angles, let's remember what the word acute means. Acute implies that it is less than 90 degrees. Obtuse implies that it's going to be bigger than 90 degrees, but less than 180. Remember, over 180 is a reflex angle. And then number 5, where they're talking about supplementary angles, that means they're going to add up to 180 degrees. All right, let's go ahead and go down and take a look at question number 6. In question number 6, they say that angle 2 in this illustration down here now is 110 degrees, and we're supposed to find angle 4. Now there's a couple different approaches you can use here based on what we're going to see or have already seen in Chapter 7. The easiest is that 2 and 4 are directly across from each other. When they're directly across from each other like that, formed by the same lines or line segments or rays, and as you can see, this line is common to both and this line is common to both. That's why I'm saying they're formed by the same in this case lines. Those are what we call vertical angles. Vertical angles are congruent. And remember, congruent is the fancy way to say equal. So if angle 2 is 110 degrees, then angle 4 must also be 110 degrees. The other way to go about this problem is you can go kind of around the illustration from 2 to 1 and then 1 to 4, or 2 to 3 and then 3 to 4. Doesn't matter which way you go, the work is actually identical here, but let's go with 2 and 3. If we look at 2 and 3 and kind of cover up this stuff down here, what you see is that 2 and 3 together make a line. A line, by definition, is 180 degrees. That would really be a straight angle if you want to think of it in context of Chapter 7. So those two together would have to make 180. Well, if we know that this chunk is 110, then this chunk has to be 70, because that 110 and 70 are how I'm going to make my 180. And then we're going to look at 3 and 4 and notice that 3 and 4 together also make that straight line, they make 180 degrees. So this and this have to add up to 180. Well, this is 70, this is 110, and of course those two together do make 180. It's the exact same logic going the other way from 2 to 1 and then 1 to 4, and the numbers actually would be identical. And you can apply that same approach when you're working through question number 7. Notice they're just saying that angle 1 is n. What I want you to remember is that together, n and whatever other angle you're going to work with there, if you're going to go for the idea of supplementary angles, has to make 180. Keep that in mind. Okay, question number 8 says the diagram shows the intersection of 3 roadways on a map. Based on the diagram, what should be the measure of angle ECD? Now we have to make sure we see what ECD is here. ECD goes from here, E, to the middle, which is C, and off to the right, which is D. So they're talking about this angle right here that I'm showing in the purple pen there. Okay, so we're supposed to find out what these angles make when combined. Now, here's the trick. What you have to see is that this angle that's marked 30 degrees and that this angle here that has part of the right angle in it are actually vertical angles. If we cover that up, you can see they make the same type of setup that we saw up here in 6 and 7. And what we learned is that when those angles are across from each other, they have the same measure. So since this is 30 degrees, this is also 30 degrees. Now, while you might be looking at it saying, well, that doesn't really help me, that's actually outside the illustration, it actually does help me quite a bit, because we know that these two angles over here, this AC D1 and DCF, are both shown to make that right angle. Well, if we know that this chunk is 30 degrees, that means that this chunk has to be 60 degrees, because that 30 and 60 are going to be how I get 90. And of course that's going to work for me because that 60 is part of the right angle. Alright, and then this one over here by itself is a right angle. You can see that classic L or T shape that we've talked about already in this presentation setting up there. So that's 90. So if this is 90 and this is 60, we can add those together to get my answer for ECD, which is 150 degrees.